All right, welcome to this lesson, Unit 3, Lesson 5, the shape of the graph at the roots. We're going to be talking about other ways to graph polynomial functions, adding to our knowledge of what end behavior and our knowledge of what maxima and minima are. We're going to now include sign charts and multiplicity. So we're going to first make a sign chart. We can graph a polynomial function without a sign chart using the end behavior and the roots and also the multiplicity. But in calculus, you need sign charts when you do derivatives. So I'm going to show you them as well. So when you make a sign chart, the first thing that you do is you have to find all the zeros and use them to split up a number line. So I'm going to do that part with this first example here. So the zeros, if we set each of these factors equal to 0, remembering x plus 0 is the same as x, we have at 0, at negative 4, at positive 1, or we could just say 1, and at negative 2. When I look at those zeros, they split up the sign chart, the number line into different values. So we have a root at 0. We have a 0. I'm going to put a 0 above any number where there's a 0. 1, 2, 3, 4. We have a 0 at positive 1, negative 1, negative 2, negative 3, negative 4. We have a 0 at negative 4, and we have a 0 at negative 2. So this equation has 4 zeros, and it's already factored for us, which is nice. Okay, and then some people do this by making an actual chart. If you can do it without that, it's fine. But I'll make a chart for the first one just so you can see how it goes. So we have to use all the factors. We have 4 factors. Okay. So our factors are x, x plus 4, x minus 1, x plus 2. And then we have the areas that this was split up into, our number line, what it was split up into. So it was split up, if we continue this number line out a little bit, just so we can see for sure, it was split into regions that start with negative infinity to 0. And then we have some other regions that it's split up into as well. Let's see, we have 1, 2, 3, 4, 5. Okay, so it's split up into 5 regions. So the first one is negative infinity to 0. Then we have negative 4 to negative 2. Then we have negative 2 to 0. Then we have the region from 0 to 1. And then 1 to infinity. So we put that across. All right, so what we're going to do is we're going to test a number in each of these regions because this number line represents the x-axis. And we're going to find out if the graph yields out a positive value or a negative value. We don't need to actually know what that value is. We just want to know if the graph is going to go above the x-axis or below the x-axis. So the first one I'm going to do is negative infinity to negative 4. Yeah, up to negative 4. So I'm doing this one first. So I'm going to pick a number in there. I guess I'll pick negative 5. So if x is negative 5, then x is negative. Negative 5 plus 4 would be negative 1. It would be negative. Negative 5 minus 1 would be negative. Negative 5 plus 2 would be negative. And if I multiply a negative times a negative times a negative times a negative, all those negatives would multiply to become a positive value. So the y value would be positive, which would mean the graph would be above the x-axis. All right, and we're going to do this for each region of this. Then I'm going to pick a number from negative 4 to negative 2, which is going to be, I guess, negative 3. Negative, this would be positive, negative, negative. So the overall value would be negative, which means the graph would exist below the x-axis. Okay, some people put the negatives down here and some people put them up here. It doesn't matter. It's up to you. Okay, whichever you want to do. So it's up to you. You can do negative because it's below or negative between them there. It doesn't really matter. All right, let's do the next one. -2 to 0. I guess we'll use -1 if we're going to do this area. Negative, positive, negative, positive. So that's going to end up being positive when we multiply those. And it doesn't matter how many plus or minus signs you put in there, just enough to fill it up so you know that everything in there is positive, enough to be above the axis. Okay, now we got to do from 0 to 1. Now in this one, it's going to be a little funky because we're going to have to use a fraction because everything between 0 and 1 is fractions and decimals. Positive, positive, a half minus 1 is negative a half, and that's positive. So that's going to be negative. And then the last region, I already did that color. From 1 to infinity, I guess I'll just put in the number 2. So we have positive, 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 positive. So it's positive. Everything here up to infinity is positive. And so that just lets you know where your graph is above the axis and where your graph is below the axis. Now, this next example just involves one that is not factored. So you should feel free maybe to pause the video and do the problem and then come back and check it. So if you're going to do that, pause it now. Otherwise, I'm going to go ahead and solve it out. So we need to factor it. So I'm going to take out a GCF of x, and I have x to the third. Oh, no, I'm going to have x squared, sorry, minus 3x minus 4. Okay. Oh, wait a minute. I wanted to show you this previous one. I did graph it on Desmos, the one we just did. So I do want to show you the graph that it is up and then down and then up and then down and then up. Let's look at our graph on Desmos. Here it is. It's above, then it's below, then it's above, then it's below. So we're above, we're below, we're above, we're below, we're above. So those regions agree with what we got on our sign chart. Okay, so now I'm going to finish this one. X times x minus 4 times x plus 1. That is our fully factored polynomial. So that means we're going to have zeros at 0, at 4, and at -1. So I will make my number line. Actually, for this one, I'm not going to make a sign chart. Yeah, I don't really think we need it for this one because it's kind of smaller. Okay. 0, 1, 2, 3, 4, 5, -1, -2. Okay, so I need to realize that I have zeros here at 0, at 4, and at -1. And I'm going to test a number in each region. So anything to the left of -1, I guess I'll test -2. So if I put a -2 here and a -2 here and a -2 here, I'm going to have a negative times a negative times a negative, which is going to turn out being negative. So all over here is negative. All right, now I'm going to do a different number. Okay, I already marked my zeros on there, so I'm going to get those out of the way. We don't need them anymore. All right, now let's put a number between -1 and 0. I'll put in -1/2. That's going to be negative. -1/2 minus 4 is going to be negative. -1/2 plus 1 is going to be positive, so it's going to be positive. Okay. Now I'm going to put in, see, instead of making one of these giant charts, you can do it this way if you like to. As long as you have the sign chart, which is the number line with the signs on it. That is the actual sign chart. All right, so I'm going to I'll put in 1. Okay, to check this area, I'll put in 1 because it's in there. You can put any number in there. So if I put in an x of 1, that's positive. 1 minus 4 is negative. 1 plus 1 is positive. So it's going to be negative overall. Okay. And last but not least, I'll put in 5. All right, so 5 is positive. 5 minus 4 is positive. 5 plus 1 is positive, so it's going to be positive. So if we look at the graph for this to check our work, we should see that the graph is below, then above, then below, then above those roots that we found. Below, above, below, above. So there's the graph. It's below, it's above, it's below, it's above. I also have the factored version here, and you can see that all that happens when I click from one to the other is it changes colors, which means we definitely factored it correctly. Okay, so I should have turned that off. I want to go back to here. Now let's talk about, now that we know how to make a sign chart to find where the graph is a below and above, we can also use multiplicity in conjunction with our end behavior rather than a sign graph to graph a polynomial function. So let's talk about what multiplicity is and what it means. So in factored form, the multiplicity or power of each factor has a graphical significance for the x-intercept. This is true. The multiplicity, I say, is the power of each factor. Multiplicity is the power of each factor. So what we're talking about up here is like if I were to ask you the multiplicity of this factor x, it would be 1 because its exponent is 1. The multiplicity of x plus 4 is 1. The multiplicity of x minus 1 here would be 3 because it has a power of 3. And the multiplicity of this x plus 2 factor, or the root of negative 2, is a multiplicity of 1. So you can talk about the multiplicity of the factor or the root that the factor gives. Here, our multiplicity is 1 and 1 and 1 for roots of 0 and 4 and negative 1. They all have multiplicities of 1. So if the multiplicity is odd, then the graph is basically going to slash through the x-axis. If the multiplicity is even, the graph bounces off the axis. So if the multiplicity is odd, when we're talking about an x and y axis at a particular point, then that means the graph goes through the x-axis. If the multiplicity is even, then that means whether the graph's going from above or below, that means it bounces off at that point and goes back the other direction. And then the higher the multiplicity in either case, the higher we're going to call it a hug to the x-axis at the x-intercept. I'm going to talk to you and show you some examples of what that means. I have some little hyperlinks here going to a couple of Desmos graphs I have created. So I'm going to go into my document here, and I'm going to click on that first hyperlink so we can look at what happens with odd multiplicities. Okay, so if we graph a multiplicity, I'm just graphing y equals x, or x to the first. It has an odd multiplicity. You can see it's very linear because it's the line y equals 1x plus 0. It has a straight slash through the x-axis. If I increase that multiplicity to 3, you can see, as opposed to the other one, as it goes to the x-axis, it starts to hug around a little bit and approach it at an angle, and then hugs the axis a little bit more before it goes away. So it hangs out close to the x-axis or hugs it as it moves away on either side from the intercept. A power of 5 gives you even more of a hug. 7, 9, and my classes always love it when I do something ridiculous like a really high power. So let's just go super psycho here and do like x to the 23rd. All right, you see how it almost starts to look like a right angle? Let's do it to the 222nd. Oh my goodness, that is such a right angle looking there. That is like some crazy hug. The more you do, the more right angle it looks like. Of course, we weren't going to be graphing anything like that, but just so you can see, okay? Now I have this little play thing here. If I turn, we have a little like a dynamic one where you can just see it move through. As the power is increasing, I should turn this on. As the power increases, it hugs more. As the power decreases, it hugs less. As it increases, it hugs more. As it decreases, it hugs less, and so forth and so on. Now let's look at the even, which is a hug bounce rather than a hug slash. So I'm going to turn this off for now. As soon as it pops up, we're going to turn that off. And here's your basic x squared, your basic parabola, which is bouncing off the x-axis at its x-intercept of 0. If you do a power of 4, it still bounces off the axis, but it hugs on either side. And 6, and 8, and 10, and have fun. You can do something like a big power, and again, it will hug more and more and more. And then we do have a player here that we can play this, and you can watch it shift through these dynamically, starting with that. So, yes, there we go. Now you'll notice that on this one, I use the expression 2x because every even number is a multiple of 2. So no matter what you put in, 2k, what you put in for k, you're going to get even numbers because I wanted it to only do even bounces. And then on the other one, I have 2k plus 1 because every odd number can be thought of as one more than an even number. So no matter what you put in for k, it's going to make that exponent odd. So we've seen our multiplicity, and now we're going to practice graphing with some multiplicity and some end behavior. Don't forget your end behavior. Okay, you'll need the first term of the polynomial. If the polynomial is factored, as in this one, you're going to have to come up with the first term. Let me show you what I mean. We can go back to the notes for a little bit. So if it's in factored form, get it by multiplying all the first terms. To get the y-intercept, or the last term, you need the term at the end, and you get it by getting the last one. If there is a GCF of ax, it's ax plus 0 and automatically makes the y-intercept 0. Absolutely, because if you have a factor of x, that gives you a root of 0. And if you multiply that times all the other ones, it's going to change them to be 0. All right, let's see how this process flows in working with this first example here. So we want to sketch a rough graph of this polynomial using all the key features. All right, when I do these, I typically do not put tick marks on my y-axis because the y values, we really don't know what they're going to be. We're just going to do a rough sketch. So we do know what the roots are. We know that this 2x equals 0 is going to give us a root of 0. This one's going to give us a root of 3. This one's going to give us a root of -2. And this one's going to give us a root of 7. So I'm going to make sure there's 7. 1, 2. This is 3. Here's 0. Here's -2. So we know that our graph has to pass through those x-intercepts or hit those x-intercepts. Okay, so that's our x-axis. I'm not going to tick mark the y-axis though. Now we have to look at the multiplicity of each one so that we know if it's going to bounce or slash or hug. When I have you graph them, I will stick to multiplicities of 1 or 2 or 3 because 1 will be a slash, 2 will be a bounce, and 3 will be a little bit of a hug as it goes through. And then it's hard to tell one hug from the other when you talk about higher powers. So I usually stick to 1, 2, and 3 just so you can do each one. So at this one, our 0 has a power of 1, so it has a multiplicity of 1. That's our multiplicities. This is our zeros. Okay, 3 has a multiplicity of 2. -2 has a multiplicity of 1. And 7 has a multiplicity of 3. So you can write that there. You can also put it on the graph if you want to. You don't have to, but sometimes it helps. Okay, now we need our y-intercept and our end behavior. We know our end behavior comes from the actual polynomial foiled out. It comes from the first term. So if you were to FOIL all this out, which I do not recommend doing it, it'll be like very cumbersome. But at some point when you have 2x plus 0 times x minus 3 times x minus 3 times x plus 2 times x minus 7 times x minus 7 times x minus 7, which you're not going to have to write this out after you see how it's done the first time. The very first term in your foiled out mess will come from multiplying, when you're doing your end behavior, the first one times the first one times the first one times the first one times the first one. All the first terms multiplied together will give you the first term. So 2x times x times x times x times x times x times x is going to be 2x to the 1, 2, 3, 4, 5, 6, 7. So that would be 2x to the 7th for our end behavior, which means it's an odd power and it's positive coefficient. So it's going to go up to the right, down to the left. Okay. Or in other words, as x approaches negative infinity, f of x approaches negative infinity. As x approaches positive infinity, f of x approaches positive infinity. So we know here it's going to go like this and like this. Okay, we just got to figure out the middle. Where's our bounces and our hugs and our slashes now? We also need our y-intercept. And the y-intercept is always the last term in the foiled out polynomial. And to get that, you multiply the last times 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 the last. And since this one is a 0, why bother multiplying the rest of it? Because it's just going to 0 times everything is 0. So it turns out the x-intercept is also the y-intercept here, okay? Which it would have to be if 0 is an x-intercept. Because you can only have one y-intercept or it's not a function. It won't pass the vertical line test. All right, so now we're ready to finish drawing our graph with our multiplicities. Okay, so I'm going to start at 7. You can start from the right and go to the left, or the left and go to the right. It's probably more technically correct to go left to right. For some reason, I always start the other way, though, so it doesn't matter. So my multiplicity at 7 is a 3, so I need to show a little hug as I'm going through there, okay? So it's got to be huggable there. At negative 2, at 3, the multiplicity is 2, which means it's going to bounce off and go back down. We don't know how far it goes down. That's why we don't put tick marks on the y-axis. The multiplicity at 0 is a slash. We don't know how high it goes up. And then at 2, it's a slash because it has a multiplicity of 1. So that's a very, very rough sketch. We don't know how high up and down it goes in the middle, but we do know it bounces at 3, it has a little hug at 7, and it slashes at the other 2. If we want to look at this on Desmos, I pre-programmed it in so that you can see it. It's this one. So we can see right here, we got a little bit of hug going on right here. We have a bounce here, a slash at 0, a slash at negative 2, and this sucker goes up way, way, way high. I could throw a coefficient in front, a fraction, and squash it in more, but we're just going to leave it the way it is because we're just wanting to get a rough sketch. All right, the last one, we are going to have to factor it ourselves. So if we factor this one, okay, we're going to have to use any factoring techniques we have because we have more rules that we have to learn before we can do non-factoring techniques. Looks like I can do a factor by grouping with this. I can take out an x squared on both those. So that would be x plus 2. I take out a negative 4 on both these. That's x plus 2 when I do that. So I have x squared minus 4 times x plus 2, but this factors more into x plus 2 times x minus 2 times another x plus 2. So we have 2 of these. So our factor is x minus 2 times x plus 2 squared, which means our zeros are at 2 and negative 2. And the multiplicity on those, at 2, it has a multiplicity of 1 because that's the power here. And a negative 2, I'm sorry, I like to write these with Roman numerals. It has a multiplicity of 2. So if I'm going to graph this, I know I'm going to have a root at 2 and at negative 2. This one has a multiplicity of 2. This one has a multiplicity of 1. And then to get my y-intercept and my end behavior, that's going to be easy because it's here. My y-intercept is -8. So I know we go down to here. That's as much as I know there. I'm just going to say this is where -8 is. These points are included as well. And then our end behavior, because we have a positive and a cubed, our end behavior is going to go like this. It's the same as the last one. So as x approaches -infinity, f of x approaches -infinity because it goes down on the left. As x approaches to the right, positive infinity, f of x approaches positive infinity because it goes up. So we know it's going like this on the ends. Now, at -2, there's a bounce, so it's going to go back up. Oh, wait a minute. I drew it on the wrong side. I'm sorry. Sorry. This one should be going down over here. That didn't make sense. That's why. So at -2, there's a bounce. It goes through my y-intercept of -8, and then here it goes through as just a slash because of the multiplicity of 1. So let's look at our Desmos graph of that one to see that it coordinates with what we're expecting to see. Yep, there she is. Factored and unfactored form, confirming our factoring was correct. A bounce at -2 going down to the left, y-intercept at -8 and going up to the right. So that's a look at our notes on multiplicity and graphing with sign charts. Join us for the next lesson where we will start to talk about roots and zeros and finding them on polynomials that we can't factor.